So we will start with problem 7. Gate AB is a quarter circle of 10 feet wide and hinged at B. Find the force F just sufficient to keep the gate from opening. The gate is uniform and its weight is 3000 lb. So here, in this problem, we want to find what should be the force F required to maintain equilibrium of the gate. Okay, this is the question. So, in order to know what to do, first we are interested in the gate, okay, because the force F is applied on the gate. So we will take the gate as our system and we will draw the free body diagram of the gate. So first, of course, we have force F, the vertical force F, and we have the weight of the gate, which is given to be 3000 lb, and we have the hinge action, of course. So we have here a reaction at the hinge level. So we have Bx and By, but we will see that we don't need them because we will do sum of moments about B equals 0 to ensure equilibrium condition. Okay? And we have also the action of water on the gate. This is the most complex force here. How to determine the action of the fluid on the gate. Okay? In order to compute F vertical and F horizontal, we should divide it into two components. Okay, so we have a total resultant force because here it's a curved surface. Okay, we have a curved surface, so the water will act on the curved surface. At each point, we have the pressure is perpendicular to the surface, but when we do the summation, we can come up with one result. Okay, so it's a distributed load on the inclined surface. It's inclined and curved here, so it's a curved surface. So we will end up with a resultant force that can be divided into two components, a horizontal component and a vertical component. Okay, and the objective here is to find what are these two components. So first we will start by the horizontal component. From the course material, if we have a curved surface, the horizontal force is equivalent to the force acting on the projected surface of the curved one. So this is your curved surface. If you do the projection, you get a vertical surface. Okay, your vertical surface is a rectangle. So we have a certain width. We have a certain width towards perpendicular to the paper, to the board. Okay, so the width here is given to be I don't know if, yes, they told us it's 10 feet wide, so this is 10 feet. Okay, and we know that the circle is of radius 8 feet. Okay, so here the distance from here to here is 8 feet. So the projection of this curved surface on the vertical plane will give us a rectangle of width 10 feet and of height 8 feet. Okay, now from the course material, the force acting on a vertical surface should pass by the center of pressure, and as magnitude, it has a magnitude of the pressure at the center of gravity, or at the centroid of the area. Okay, if I take the following area, the centroid, which is at the middle here, corresponds to a height of 4 feet. Okay, so this is the centroid corresponding to a height of 4 feet. So I can say that the pressure at this level, I am interested in the pressure at the level of the centroid. So this is the centroid. Okay, the centroid is at a depth of 4 feet. So I can say that F horizontal is equal to the area of the projected surface, which is a rectangle. So the projected area times the pressure at the centroid of the projected area. So I get that it's equal to the width, which is 10, times 8, times the pressure. Okay, so for the pressure at this point, I computed from gamma of the fluid, so times gamma, times the height. The height here is 4 feet. Okay, so this is the depth of the centroid. So from this expression, I can find my horizontal force acting on the projected area. Now, to find the point of application, we know that it should pass by the center of pressure. And because it's a rectangular surface, okay, and you have here, you have above this fluid, it's a free surface, you have the atmosphere. So you can directly use the result we have developed together last time. You can directly say that the center of pressure is at 2/3 from the free surface. Okay, so this is 2/3 of 8. So this is the location of the center of pressure here. And if you take from the bottom level, it's at 1/3. Okay, so we can say that F horizontal is at 2/3 times 8 from the surface and at 1/3 of 8 from the bottom. So now for the horizontal force, we know everything. We know the point of application and we know the magnitude. Hadi, yeah, but just 1 minute. Someone is asking a question. Hadi, you are asking, can you repeat how we know the area when finding what? The FV? I didn't understand, Hadi, your questions. Can you repeat it, please? What do you mean by F? You mean for F vertical? Yes, for F vertical, I will repeat it, okay? So let us finish now with F horizontal. Yes, who was asking a question? Yes.
خلاص دكتور ماشي الحال.
Okay. So now we are done with F horizontal. Now we will move to F vertical, okay? Last time, we have seen a similar concept. And we have said that if we have a curved surface or an inclined surface, okay, and we have, like here, if you look at the level of water, the level of water was like this, and suddenly we started with a curved surface. If I continue the level of water, if I imagine that I have water here, I can see that above this curved part, I have a certain volume. Okay, this volume that is not filled with water is called the missing volume. Okay, so this part, this is what we call the missing volume of water. Missing volume of water. Okay, we have demonstrated last time that if I have a surface and I want to find what is the vertical force of the fluid on it. Here, as you can see, the fluid is below the surface. So if you want to find the effect of the force on the surface, you can say that it is equal to the volume of the missing part. Now, to understand why, okay, what you can do to see it more clearly, you can take as control volume the water here in this space, okay? If I consider the water here as my system, what are the forces acting on this system in the vertical, let's say in the vertical direction, okay? I am interested now in the forces in vertical direction acting on this part of my fluid, okay? So I will draw it here again and put the forces acting on it. So this is the control volume of fluid I am interested in. I will put all forces acting on it. What I have is, first, of course, I have this surface is vertical, so the force acting will be horizontal. So from this side, I have F horizontal, I will call it F horizontal 1, okay? And as I have here a curved surface, the force on the curved surface will be divided into two parts. One that is horizontal, okay, and one that is vertical. And these two forces represent the effect of the curved surface on the fluid, okay? So this is FH2, and this is FV. But as you can see, and this result was already used by us because we can demonstrate it here. In the horizontal direction, you only have FH2 and FH1. So FH1 should be equal to FH2. This is why we directly said here that FH is equal to the force acting on the projected area. Because look here, what do you have? FH1 is acting on what? Is acting on a rectangular surface. It's acting on a rectangular surface that is equal to the projection of the curved surface. This is why here directly we said that to find FH, we find the force acting on the vertical projection. Now, concerning the vertical direction forces, what do we have along the vertical direction? We have FV to find, okay, and we have the weight of the fluid, okay, and we have the pressure from the pressure forces from the bottom level, okay. Please keep in mind that here my system is, in this figure, my system is water under the curved surface, under the curved surface, while in this figure here, my system is the curved surface. So here my system is the curved surface, okay. This is why if you look well, FH and FV here are opposite to FH and FV here, because by principle of action reaction, okay, the water will act on the surface in this direction. So here the resultant will be, this is the resultant of water on the surface, while here by action reaction I have the opposite. This is the resultant of the surface on water, okay. So when I represent my system as water, I represent the force of the surface on water. When my system is the curved surface, I represent the effect of the fluid on the surface. And they are of opposite direction, but same magnitude, okay. Now, going back to the water system, how to find F vertical? To find F vertical, I simply say that it's equal, so just let me name the forces here. This is F vertical of the surface on water. This is the weight of water in my system, and this is the force from bottom. How to find the force from bottom? The force from bottom is equal to the pressure at the bottom times the bottom area. Now, what is the pressure at the bottom level? To find the pressure of the bottom level, I will go back to this figure, okay? In this figure, this is my bottom level. I have the pressure is the same everywhere on this line because it's a fluid at rest and I am moving in a horizontal plane. So I can say that the pressure at all these points is equal to the pressure here, for example, is due to the column of water above this point. So to find the pressure at this point, it's simply gamma of my fluid times this height. And this height is equal to the radius of my circle, which is 8 feet. Okay? So here if I replace, I have the pressure is gamma of my fluid times 8 times the area. The bottom area is 8. So as you can see here, this is 8 and I have a width of 10. So times 8 times 10. Okay. Now, if I want to do an analysis of this term, okay, this term is equal to gamma times which volume times V total. What do I mean by V total? Because you are multiplying A by H here. So here, let me replace it here. It's gamma times the bottom area times the total height, which is equal to gamma times total volume. And what I mean by total volume is the volume of this whole part. Okay, so let me clear it so that it is clear for you. If you look at this figure, okay, this is your H. This is H, okay? If you multiply H by the bottom area, what do you get? You will get this volume. So H times A will give you this. This is the area times the depth. So you will get the volume, the total volume, which is composed of two parts. So let me put it in a clearer way. So here, as you can see, it's divided into two parts. This is called the missing part. This is part 1, okay? And part 2 is the volume, is the real volume of fluid. But when I do H times bottom area, what do I obtain? When I do H times the area at bottom, okay, I get the volume 1 plus volume 2, which I will call V total, okay? And this total volume is equal to volume 1, I call it volume of the missing part, volume of missing part, while V2 is equal to volume of water, okay? This is volume of water. So now, if you go back to your system, and you do the analysis in vertical direction, I will draw it again. Okay, you have from the bottom level, your force is equivalent to gamma times V total. What is gamma times V total? It's the total weight, okay? So it's equal to gamma times V total, which is equivalent to total weight, okay? Now, from this part, you still have the weight of the volume of water inside your control volume, which is the actual volume of water. So this force is what is W2. It's the weight of water under my surface. So this is W of part 2. And you have to find what is FV. You still have to find what is the vertical force of the surface on water. You still need to find this force FV. So to find FV, all you have to do is to say that FV, you say sum of Fy equals to 0. Okay, what do I have along Y direction? I have plus W total minus W2 minus FV equals to 0. So I conclude that FV is nothing than W total it's equal to W total minus W2, which is equal to, if you look in the figure, it's equal to W1. This is the weight of the missing part. This is why I tell you, you can directly use this result, okay? You can always demonstrate it again, but you can directly use it. So you can say that the vertical force of the surface on the fluid is equal to the weight of the missing part. Now, by principle of action-reaction, here, because Fv is downward, since it represents the action, so here this is the action of surface on water. But what you want in your problem is the action of water on the surface, because you are interested in the gate. This is why what you do, you represent the opposite force. So this is why here Fv is up and Fh is towards the left. Okay?
دكتور
Yes.
دكتور هون عملوها يعني بطريقة كتير عادي، عملوا اف في هي الاف بوتوم طالعة طلوع ماينس الويت صح؟
لا، هن قالوا لك read what they said. The vertical force equals the weight of the missing piece of water above the gate. This is what we did. They directly used the result without demonstration. So I told you you can directly use it, but I just explained it because one of the students was not understanding the method to use it, how we can demonstrate. Okay? So here, what they did, they said F vertical is equal to the volume of water above the surface, equal to the missing part. They told you it's the missing piece of water. This is the missing piece of water, okay? In order to find the weight of the missing piece, what should you do? You should consider the weight of the total piece, then you subtract from it the weight of this part. And this is what they did, okay? So they said F vertical is equal to gamma of part 1 is equal to gamma total minus gamma 2, okay? Now what is gamma 1? What is W1, sorry? It's the weight of the missing part, okay? W total is the weight of the total part. The total part has a volume of 8 times 8 times 10. This is why they did gamma times the total volume, which is 8 times 8 times 10, minus, what is W2? W2 is the weight of this part, which is the quarter of the circle. It's equal to, this weight is equal to gamma of the fluid times this volume, which is V2, okay? Now to find this volume, you do pi times R squared, which is 8. So pi times 8 squared times the width, which is 10, okay? And this is how they found F vertical. So I told you, you can directly use this result. When you see that you have a missing part of a fluid, then the action of the fluid on the surface will be equivalent to the weight of the missing part, okay? What I did is just the demonstration of this. Any question on how we find FV?
دكتور يعني نحن الاف في على طول بنطلعها انه هي الويت اوف ذا ميسنج فوليوم.
هي الويت of the missing part إذا في missing part أكيد. يعني here, look, why we should do this here? Because your surface, as you can see here, the fluid here is below your surface, okay? So you cannot use another method. يعني if you want to use another method, you can, but you should do integration. It's very complex. So if you don't want to use the free body diagram I gave you, here you have a distributed pressure, and at each location, last time we found another method. Why? Because the surface was like this. It was horizontal. If you have a horizontal surface, you can find the pressure at each point because it's on the same level. But here, what is the problem? The problem is your points are at different locations. So, for example, the pressure at this point, you know it. it's equal to the atmospherical pressure. It's equal to this level. But if you go to this point now, it's a different pressure. It's the pressure at this level. And if you take another point, it's another pressure. So you go back to the course material, because the course material did the, if you want, we did the demonstration. You can do it by integration. So you should find the pressure at each location and then integrate to find your total force, which is very complex. In order to not do this, you can use directly this result, because you have that it's a curved surface and we have a missing part of fluid above it. So we can directly say that the effect of the fluid on this surface is equal to the weight of the missing part. Okay? Any other question on this? Let me check the chat. Ali, which area do you mean? Ah, okay. So Ali, did you understand the question you asked about?
Yes, doctor, thank you.
Okay. Now, okay, we found the magnitude of FV, but we still have another issue, is the point of application. To know the point of application of this force, since this force is due to the weight of the missing fluid, so it should pass by the centroid of the missing part. Okay, so to find the point of application, it will be the centroid of the missing part. This is the missing part. Okay, and from mass, if you want to find the centroid of an area, all you have to do, you can apply the rule that x bar, x of the centroid, times the total area is equal to sum of, it's equal to sum of xi ai. What I mean
دكتور
by
هلا
yes.
شو عم نعمل؟ جبنا الاف هوريزونتال واف فيرتيكال، هلا شو؟
مظبوط. هلا عم نجيب point of application of f vertical. Okay. يعني انت you need to know not only the magnitude, you need to know what is the point at which f vertical is passing by, because you need to study the equilibrium of your gate. And when you have a rigid body in 3 dimension or in 2 dimension, in order to solve for equilibrium, you should find the magnitude of your forces and you should know their points of application. Okay, so we have found the magnitude of FV, but we still need to know what is the point of application of FV. And FV should pass by the centroid of this point. Okay, to find the location of the centroid, we will apply the following mass rule, that x of the centroid times the area we are interested in is equal to sum xi ai. Okay, now you can say that this surface 1 is equal to the total surface minus surface 2. Okay, this is why if you want to find the centroid, you say that xc of part 1 times area of part 1 is equal to xc of the total part times the area of the total part minus x centroid of part 2 times A2. Okay, this is the method to find the centroid of part 1. Let us do it together. If you go to this figure here, so they illustrate for you that the part we are interested in is equal to this whole area minus the area of the quarter of surface. Okay, so if you want also, instead of saying x bar times a total equals to some xi ai, this is derived from the idea in statics. I think you have taken statics course, yes? You have taken the statics course?
Yes.
Okay, so in statics, if you want to find, if you have several forces and you want to reduce them to one force, what do? You say that in order to reduce them to one force, this force should be equivalent to both. So it should be equal to the summation of all forces acting on the system. And its point of application should be in a way to produce the same moment about any point. Okay, so this is what they did, and it will be equivalent to the equation we have written together. Because look, here, sum of moment about B of the resultant force should be equal to sum of moment about B of weight total minus moment of the weight of part 2. Okay, so if you look at the equation they wrote, they said the moment of this force is equal to F vertical times X. Now, what is F vertical? It's nothing than gamma. So replace F vertical. It's what? It's gamma. Okay, times V1. Okay, and you will see that here gamma and the width will be simplified. So we will go back to our equation of centroid of area. Okay, so gamma times V1 times X is equal to, what is the force here? This force represented here. This is the force of the total weight, because we have the total weight and we subtracted from it weight 2. Okay, the total weight is equal to gamma times V total. So I can replace here this term. This is gamma times V total times what? The distance from the centroid of this volume, which to point B, which is equal to this distance, which is X total, is equal to 4. Okay. Minus this part is due to the weight of the water in the quarter of circle. So this is minus gamma times V2, okay, times the distance from here to here. This corresponds, this is X2. So this is X total and this is X2. Okay, so now if you simplify by gamma and if you simplify the width, you will go back to the relation X1A1 is equal to sum Xi AR. Okay, so your only unknown in this equation is what? Is X, which is the position of your vertical force. Do you want me to repeat this part? Any question on this part? Okay.
Can you please repeat it?
Yes. Concerning the point of application. For
Yes,
the
yes.
person, okay. So what we want to do now, okay, we found that F vertical magnitude is equal to the weight of this part. Okay, the weight of this part. If I draw it here. So F vertical is the weight of this part. To know the point of application, F vertical should pass by the centroid of this part. Okay, so you should find what is, so I will call it, so let's consider this is your point, this is your centroid, for example. Okay, this is your centroid C. You want to know what is the location of C in order to know what is the point FB should pass by. Okay, so this is your vertical force. Your vertical force should pass by the centroid of the missing part. So our purpose here is to find what is the distance between B and the centroid. Okay, because we want to locate the force FB. If you want to find the centroid of an area, what do you do? In math, what do you do? Do you know how to find the centroid of an area? Please, for the one who is asking me, are you hearing me? Do you know how to find
Yes.
the centroid of a point of an area? What is the formula you use to find the centroid? If I give you, for example,
هي force times distance مظبوط.
yes, look, here you can think it, you can think in two ways. You can think in areas or you can think in forces. You know why? Because they are proportional. Because what is the force due to the weight here? It's equal to gamma, okay, times the volume. And what is the volume? It's the width W, width, which is here 10 feet, times the area, okay? But because gamma and the width are constant, so you can think in centroid of areas. Or as you told us, you can think about forces. It will be equivalent because when you simplify gamma and the width, which are constant, you will go back to the idea of the centroid of area. If you want to find the centroid of an area, you can use the following formula. You use that x of an area. Here you are interested in this area, area 1, okay? X of 1 times area of 1 is equal to, what should you do here? What is your area here? Look, this area is what? Is the square minus the quarter of circle, okay? So from math, you can say that x1a1 is equal to x of the square times area of the square minus x2, which is for the quarter of circle,